Hello, everyone. Thank you for joining us today. My name is Tim Bardzol, and I'm a product manager in the demand side management group at Silver Spring, where I focus on demand response hardware and residential demand response more generally. We'll be taking a thorough look at upgrading your load control programs to take advantage of smart grid and two-way connectivity in today's webinar. Silver Spring has worked with leaders in the industry to overcome legacy system and communication limitations. And today we'll be sharing that experience and outlining the process for building a business case for smart grid-based demand response, with a focus on the value associated with replacement of legacy direct load control infrastructure. To start us off today, I pulled some data from FERC's most recent assessment of demand response to highlight how mainstream and vital demand response has become to the U.S. electric grid. As of last December, there were approximately 1,500 retail DR programs in the United States, which taken together add up to approximately 36 gigawatts of potential peak reduction if all these programs were called upon at the same time. And this 36 gigawatt number, represents a 25% increase in potential peak reductions just in the past 3 years, which I think is a real clear sign that the DR market is continuing to grow rapidly. Much of today's webinar is focused on direct load control programs, so it's worth noting that nearly a full third of the 1,500 retail demand response programs fall into this category. And for those who are unfamiliar, direct load control involves the deployment of devices at the customer premise. These are usually load control switches, but sometimes thermostats as well, that can automatically turn off or cycle customer appliances such as air conditioners or electric water heaters. And to date, direct load control has been the most common form of demand response that we've seen in the residential and smaller commercial segments.
But despite the growth and impact of demand response, significant challenges exist. To start, demand response solutions sold in the past have traditionally been very vertically integrated and lacked flexibility. And this has resulted in vendor lock-in and utilities just really not being able to use the technology for anything other than its original purpose. Additional challenges exist around measurement. To date, utilities have generally had to rely on statistical samples and highly manual methods to verify load reductions. This manual process is not only costly, but can lead to inaccuracies when trying to forecast future demand reductions, for example. And a final challenge I'd like to point out is customer adoption. Some of the most successful programs out there have done a really great job attracting customers and achieve participation rates of 20–25%, but we don't see those levels of participation uniformly across the industry. The good news is that the smart grid is really changing all of this by driving innovation and new solutions to solve these long-standing issues in demand response. The smart grid brings open standards allowing utilities to mix and match best-of-breed demand response technology from multiple vendors. The proliferation of smart meters allows utilities to precisely measure individual customer demand reductions in a highly automated fashion. And finally, the smart grid can provide customers with better, more personalized energy information, along with new in-home technologies to help motivate them to sign up for and stay enrolled in a demand response program. Now, looking specifically at direct load control systems, we've repeatedly seen a combination of challenges in our interactions with utilities. For starters, virtually all existing direct load control systems run over legacy one-way paging networks, which means that utilities generally don't know which switches out there are functioning and which ones really need repair or replacement. Some utilities that we've had conversations with have decided to tackle this challenge by performing site visits. So they go out and inspect the equipment every couple years, but this leads to much higher operational costs. But then if a utility doesn't perform these field inspections, what happens is over time more and more devices will fail and no longer respond to demand response events. And then when you add in communication failures that occur due to the gaps in the paging network, we've seen effective failure rates be as high as 30, sometimes even 40% on some of the oldest legacy systems. And finally, many of the legacy systems are reaching end of life, making it difficult to obtain parts needed to keep the system running. In one case, a utility that we've spoken with has literally had to resort to buying spare parts off eBay. In addition, legacy devices also don't contain recent advancements in cycling algorithms to better adapt to homes with what are known as oversized HVAC systems. Basically, these are systems that are really oversized for the house and don't need to run very often to maintain the temperature. As a result of having outdated switches without these advanced algorithms, utilities can be losing up to 20% of the potential peak reduction benefits. Last year, we introduced our Director Grid load control solution that is well suited for utilities looking to upgrade from a legacy load control system. Several utilities are currently beta testing the solution in their lab with general availability scheduled for the third quarter of this year. On the slide, you see a high-level depiction of our Director Grid solution, so I'm going to take a moment to walk you through the various components. So on the right side of the slide, you can see a third-party load control switch that contains an integrated Silver Spring communications module. This module provides two-way communications directly to the utility smart grid network, much like a communications module that's embedded in an electric meter. We're working with a number of load control switch manufacturers to integrate in this fashion to provide utilities with greater choice and control over the type of load control hardware they deploy. Also depicted on the right side is a field tool that we've developed to assist with the installation of these switches. In the middle of the picture is the Silver Spring IPv6 based network. The switches can communicate over an existing network deployed for AMI, or a network can be deployed alongside the switches for utilities that have not already deployed smart meters. And then on the left side of the picture, you see 3 Utility IQ software modules that provide the back office operational functionality. All the way to the left, you see Utility IQ Demand Optimizer. This is our full-featured demand response management system that forecasts load reductions in real time. It dispatches events over the Silver Spring network, as well as over the internet using the OpenADR protocol and other communication channels as well. And Demand Optimizer performs automated measurement verification both during and after events. To the right, you can see our Utility IQ Handoff Communications Manager software. This software manages the provisioning of devices on the network and communication of demand response signals across the network in a highly efficient way. And finally, you see Utility IQ Advanced Metering Manager. Many of our customers are already using this software for their meter-to-cash workflow. That same interval data that's being collected from meters gets fed back into Demand Optimizer so it can do the individual customer forecasting and verifications. Utilities considering upgrading from a legacy load control system have 3 options to consider. We're going to cover these options in more detail later, so I'll keep it very brief here. The first option is to simply stick with the status quo and continue to live with the limitations of the current system. Second option is to undertake a rapid upgrade whereby the entire system gets ripped out and replaced over a short period, maybe a couple years. And the last option is to upgrade as needed. So in this scenario, legacy switches are gradually replaced with new two-way Director Grid switches based on sort of natural turnover within the program. And so both the legacy and new system would get used in parallel until all of the legacy devices are replaced. And since we've introduced the Director Grid solution last year, I've had the opportunity to meet with many utilities to discuss the solution and how the technology could benefit their current or future DR programs. And the feedback from these engagements has been overwhelmingly positive. Utilities really love the technology, and they feel it addresses a true unmet need in the market, and they're eager to work to move forward on projects with us. And one thing we found that is key to getting a replacement project moving and ultimately approved is having a detailed business case showing exactly how replacement of the legacy system will generate business value. And through our work, we've identified 3 common denominators for what makes a really compelling business case for load control replacement. The first is a detailed benefit and cost comparison of replacement versus the status quo. The second is an analysis of the options that I touched upon on the previous slide around the replacement rate. So in other words, does replacing faster generate greater return on investment? And finally is an identification of any additional benefits that could be realized in the future by having a more modern load control system. To help utilities develop their own winning business case along these lines, our market insights and strategy team has developed a business case model for load control switch replacement. Ali Jochum is one of the analysts who developed this model, so I'm going to hand it over to her so she can walk you through it.
Thanks, Tim. So hi, my name is Allie Jokum, and I work here at Silver Spring on the Market Insights team. I work with potential customers and help them build their business cases for upgrading to direct-to-grid load control. During the last year or so, my team has built a financial model that leverages industry benchmarks from these experiences and helps customers crunch some numbers around what their business case could look like. Determining if the business case for direct load control replacement makes sense involves comparing the cost to replace the system to the benefits of the upgrade, or the cost you would potentially avoid. If the benefits outweigh the costs, then we have a positive benefit-cost ratio and a positive business case. On the cost side, here you see the main cost categories in a typical business case. The biggest cost involved with any direct load control replacement project will be the hardware installation and customer incentives, with customer incentives varying widely from utility to utility. On the right side, you see the benefit categories. And the primary benefits of a direct load control program is the reduction of peak demand. Peak demand is the period of highest energy use on an electrical system and is far more costly to meet than base load, or the baseline level of demand on a system. And financially for a utility, this can translate into one of two or a mix of two things: avoided energy spend on the wholesale market at peak times, or avoided capacity investments, ostensibly avoiding a building of a new, inefficient peaker plant. Like I and Tim mentioned, we've built a model that leverages industry benchmarks that we've culled from working with customers on business cases in each of these categories to arrive at some typical business case scenarios. The scenario we're going to focus on today is scenario number 1 here, and that'll be for a customer that already has a Silver Spring network deployed across their service territory, who's looking to leverage that network to simultaneously run AMI or other current smart grid application with a new load control network. The most work we've done with customers has been in this category, so this is where we'll focus. However, we'll also touch on what the business case will look like for customers without an existing Silver Spring network that either want to deploy a canopy network specifically for load control, or customers without an existing Silver Spring network who want to deploy load control and AMI at the same time. So we'll look at the combined business case for those two applications. And we'll show that the business case can actually work well for utilities falling into each of these scenarios. Like I mentioned before, the benefits side of the business case will center around avoided costs that you'll be able to realize as a result of an upgrade. And like Tim mentioned, in our conversations with our customers, we've started to hear 3 issues with current paging load control systems that are preventing you from realizing the full benefit of load control programs. The first one is that paging networks operate in one direction. That means that failed switches can't be detected and accumulate year after year in the field, steadily chipping away at the capacity of each event. We've heard that utilities with paging load control networks that are approximately 10 years old estimate that at least 15% of their switches are non-functioning, but they can't detect them without costly field visits. Two-way communications, on the other hand, allows for remote detection of field failures, meaning that you will always know exactly which switch has failed so it can be replaced. Secondly, we've heard from several customers that they've experienced low connectivity with their paging networks. Direct-to-grid switches have a much higher connectivity and use the same communications technology as AMI, which has shown connectivity rates over 99%. Our model shows that over a 15-year evaluation period, an average of at least 25% of benefits are lost annually due to non-functioning switches and coverage gaps alone. This equates to a bit over $2 million annually for a sample 1 million endpoint utility here. Lastly, switches themselves have gotten more intelligent in recent years and can now deliver 20% greater peak reduction when controlling air conditioners due to better cycling algorithms. And a final issue that's not technically quantified here is that today, because of issues number 1 and 2 on this slide, all utilities experience some percentage of free riding participants. These participants collect annual incentives, but because of faulty switches that can be hard to detect, do not actually provide any DR capacity. Direct-to-grid load control switches provide unprecedented premise-level load reduction data, allowing utilities to pay incentives to avoid wasted incentive payments. Okay. At this point, I just want to quickly expand on the point that Tim was hitting upon before and mentioned there are 2 potential deployment strategies to take when upgrading load control switches. The lines on these graphs here show the number of switches installed over time. So the first strategy is shown here on the left and involves an accelerated rollout of switches with regular replacement after the deployment for the remainder of the evaluation period. An accelerated deployment is a greater upfront cost, but also provides faster realization of full benefits. A second deployment strategy is shown on the right, and that's the organic or replace as needed strategy. In this case, you can spread the cost of deployment over time, but benefit realization is also delayed. Another thing to note here is that until 100% of the legacy switches have been replaced, back office systems for both systems must be maintained, adding a bit of cost to the scenario. The business case numbers on the following slides will focus on the accelerated scenario, but the business cases work for both and are not dramatically different. And with that, let's get to the business case that we've estimated, the reason you guys all tuned in. Okay, so here we compare the benefits and costs per participant of a load control program over 15 years in a current paging scenario to a replacement scenario. And as you can see, if today a 1 million endpoint utility achieves roughly $1,000 in participant benefit over the lifetime of the program, they are leaving 40% of benefits on the table. And again, the benefits here are avoided peak capacity costs or avoided peak energy purchases. And if we compare that to the incremental cost of the investment, which you can see in the chart below, it's more than the incremental investment. So the investment represents approximately a 30% increase in costs compared to the current scenario. Both of these cost bars include the total cost of the program, things like load control switches, hardware, maintenance, and replacement for the entire duration of the program. And as you can see, the benefits of replacing a legacy paging load control system actually outweighs the cost 2 to 1. So we just reviewed the business case for the replacement of a paging load control system where an existing Silver Spring network exists and shown that the numbers make sense. We've conducted a similar analysis for the replacement of a legacy load control system in the case that there is not a Silver Spring network in place and a direct load control specific canopy of network infrastructure has to be deployed, or AMI and load control are deployed simultaneously. Okay, and here we show those analyses. Again, all figures on this slide are in dollars per participant over the lifetime of a 15-year program. The leftmost chart shows the same business case for replacement we just reviewed, with the benefits outweighing the cost 2 to 1. The charts in the dotted lines on the right show the business cases for a direct load control replacement in the case that there is no Silver Spring network in place. The middle chart includes the cost of deploying and maintaining a dedicated canopy network. And you can see that the business case for deploying a canopy network is still around 1.8, so in a pretty high benefit cost ratio. So far, we've quantified the main benefits of demand response as they currently stand. And these are avoided peak energy purchases and or avoided peak capacity spend. But as new applications come down the pike, these two-way load control systems are going to start to yield additional benefits. Load control can also be used to integrate renewables, helping to shape load to deal with the intermittency of wind and solar generation. It can be combined with home automation systems, can be used for integrating EV smart charging, basically helping to schedule charging and shift EV demand. And finally, we've even heard of some customers selling and trading DR with neighbors, so that the certainty of capacity that comes with these two-way communications makes load control really emulate generation. And with that, I will transition back to Tim so he can tell you a little bit more about the future of smart grid-based demand response.
Thanks, Allie. So I just have 2 more slides to cover before we wrap up and take your questions. So we've gone through and shown how Silver Spring's direct-to-grid load control can create a near-term win for utilities. But I think equally as important, it also sets the stage for leveraging the Silver Spring Smart Grid platform for other demand-side management initiatives. So beyond just direct load control, Silver Spring offers turnkey demand management solutions in a number of other areas, including price-based demand response, both customer and grid-side energy efficiency, and emerging applications such as electric vehicle charge management and smart streetlights. So I think to wrap things up today, I'm just going to summarize by leaving you with three main takeaways based on what we've covered. First is our experience has shown the business case to be really the key enabler for replacement of legacy direct load control switches. We've also shown in a typical scenario, upgrading to direct-to-grid technology from a legacy system can boost load control benefits by as much as 40%. And I think the last thing I'll leave you with is that we're really here and want to help you get started to build your own business case for your load control program. So if you're interested in working with us on this, please connect with us through the webinar platform or contact your Silver Spring account team. And at this point, I'll hand it back over to John, who will take us into our Q&A section.
Excellent, Tim. Well, that was very well done, Ali and Tim. So we've had many questions coming in. Thanks for the participation from all those on the call. Let me start off with a question from a customer in Texas. This one is directed at Ali on some of the business case development concerns. Specifically, the question is, how long does it take to work through a typical business case? Ali, can you shed some light on that?
Yeah, sure. In our experience, the analysis work has been pretty quick, but what does take a little bit of time is gathering inputs from the various groups within the utility. We found that the more input we actually have directly from the utility, the closer we're going to get to a real answer. So overall, it probably takes a few weeks.
Okay, thanks. That's helpful. Hopefully that clarified a few things. Another question comes in specifically on slide 15, which reviewed the various approaches where there is not an existing Silver Spring AMI network. And in particular, one of the participants asks, is the $91 per participant representative of the cost of the canopy network? Ali, can you confirm or expand on that a bit?
Yes, that is exactly right. So the cost of the canopy network comes out to around $91 per participant.
Okay, yeah, it was a little hard to read, but the main focus there was on the total number, total dollars per participant. But hopefully you can see that clearly. And we will be making the slides available on Springboard, so you can use those for your reference, and feel free to have follow-up discussions with us. That's what this is all about. So next question, actually from an international prospect, is directed at Tim. Tim, can you talk a bit more about what load control switches are supported? What are the partners that we work with in this area?
Absolutely. So we're working currently with two load control switch partners, two initial partners, who are Cooper Power Systems and NTEC, to integrate our communication module into their load control switches. We're also having discussions with a number of other load control switch manufacturers and plan to announce some additional partnerships later this year.
Okay, that's very helpful. Let's see. Here's another question that's just come in from one of the folks on the East Coast. This one is directed at Ali, and the question is, when you're developing a business case or working through that process, which groups within the utility organization are required to contribute input? What sort of critical mass do you need to generate in terms of getting the business case together?
Yeah, so we typically gather inputs from the group running the current load control program. That'll help us calculate the current costs and the possible structure of the program going forward. Another critical group that we collect data from is the planning group. They're best suited to provide inputs such as energy and capacity costs to help calculate benefits.
Okay, and just as a follow-up to that, it looks like there was another question that came in that was along those similar lines. Do you find that coordination amongst those groups is something that is really necessary to make the business case successful?
We have some industry benchmarks, so we can certainly get pretty close without, perfect coordination. But the more cooperation we do have from utility, the closer we're going to get to a real answer.
Right. You're right. Yeah. So I think the overall process is one where it does help when there's coordination amongst the groups at the in utility. Okay, here's another question locally here to Silver Spring headquarters. And this one's directed at Tim. Tim, can you also work with devices such as Zigbee programmable thermostats, or is the only way to work in this approach is with the direct-to-grid approach that you described?
Yeah, we absolutely support Zigbee and programmable thermostats that conform to that standard. We focused quite a bit on the direct-to-grid technology, which integrates our communications module directly into the device, because we think that really provides the greatest benefit for utilities. But we also support the Zigbee standard in places where smart meters have been installed, and there's a whole array of thermostats and other devices that can be used to support load control programs in that fashion as well.
Okay, great. That's helpful. Let's see here. And here's another question fairly local to our headquarters. This one's directed at Ali. What factors have you found that most significantly contribute to a strong benefit to cost ratio in working through the business case process?
Yeah, so I would say that the number one thing, especially on the benefit side, is that the model's pretty sensitive to peak energy or capacity prices. But we have actually worked with one customer that had a very low cost of peak capacity, and we were still able to make the business case work for them. So I would definitely say peak energy or capacity prices.
Okay. Are there any other areas that you found that need particular attention, or might be worth some further analysis?
Yeah, well, on the cost side, the item that's going to vary the most is the participant incentives. So we've seen that vary really widely from utility to utility, and it can be up to 50% of the cost side.
Gotcha.
Especially over time.
Gotcha. Okay, so that's an example where the very company-specific discussions need to take place, because we need to feather into your particular program and your style of operation, and marry that with our business case model. But as we've shown, that's a fairly straightforward process. Let's see what we've got next here. Okay, this is a question from a potential customer that is interested in reporting and analytics associated with their demand response program. So Tim, why don't you take this one? Can you talk a bit about the analytics and reporting that are included with the solution?
Yeah, sure. So the analytics are really performed by our Utility IQ Demand Optimizer software. So that's taking all of the smart meter data and building up customer-specific baselines of forecasted load, and then also taking meter data during events and calculating what the actual load shed was during those events. So you get, it's giving you both a real-time forecast of how much load shed is available kind of before you push the button, and then after the event is called, you're getting in real time, the amount of megawatts that are being shed, both during and after the event, and all that's done in an automated fashion. So it's a really rich set of analytics that we've developed as part of Demand Optimizer.
Yeah, I think that's a pretty sort of common takeaway from the customers that we've engaged really in the last 12 months is that one of the real strengths of the solution is the analytics that are available to help make trade-offs amongst which programs are working, and figure out, where to invest so that, you optimize, for the business goals that make sense for your particular company. So, that's a helpful perspective, Tim. All right, let's see what we have next here. All right, here's one from the Midwest. This one is oriented towards pitfalls associated with the process of creating the business case. It sounds like somebody wants to engage. Are there particular pitfalls that you might share from your experience, Allie, that need to be avoided when creating the business case?
Yeah. So I would say on the cost side, one of the biggest pitfalls would be to not include all the costs for the business as usual or base case over the full evaluation period. What I mean by that is if you don't do an upgrade of the current system and include a DRMS upgrade with that, you're still going to have to do, a system refresh at some point anyway. So not really thinking through all of the costs involved in the business as usual case would be one on the cost side. And then on the benefit side in the business as usual case, something that sometimes isn't taken into consideration is degradation of system performance over time. So many systems are already pretty old, so over the next 15 to 20 years, devices are going to start failing faster. If they're not replaced, the benefits will slowly go away completely.
Okay, so that's helpful. So it sounds like paying close attention to the overall environment, is really pretty crucial.
Yep.
Particularly in the case of integration with back office and seeing the whole picture. And so I think that's an important thing that we wanted to get across was that our approach here is geared towards looking at a holistic solution tailored to your particular needs. All right, great. Let's see what else we have. See, here's one from a customer in Canada. This one's competitive in nature. Tim, I'll direct this one to you. How would you contrast the Silver Spring solution with the LNG product line? And maybe you can answer that directly, but also just talk a little bit about differentiation and positioning to competition in general.
Yeah, I mean, I think I'll avoid sort of a direct comparison on this webinar. But, I think we look at, our strengths of our solution being, number one, sort of our core networking technology and connectivity rates that we can provide and how that really provides the boost to benefit by ensuring that all the devices out there are reachable when load needs to be shed. As well as the performance of our network, the speed that our network operates and how that can enable utilities to do really rapid load shed across the network, which actually can support some new applications, not just shaving the peak, but also using load control for things like ancillary services. And then I think just really the completeness of the solution that we offer, not only just in terms of the devices in the network, but really all the analytics in the back office that we just got done talking about, that really provides a lot of the business intelligence for utilities to be able to run these programs much more efficiently. I think that's another key differentiator that you don't find in other competing solutions. So I think those are probably the two or three things I'd point to.
Okay, so that's a helpful perspective. So if I was to summarize that, it would be sort of a proven network that's going to be very reliable and bulletproof, so to speak, but coupled with the sort of the innovative breakthrough analytics capability that allows you to make optimal business decisions and really tailor that for your particular initiative goals and program needs. Mm-hmm. So I think that's excellent. Let's see. Well, it looks like we've got one more here. This one, let's see. So, oh, I guess that was just a comment, but that's helpful. Okay, well, I think what we'll do is then wrap things up, and in terms of next steps, you know, I hope you found that that discussion helpful. You know, for next steps, we're eager to engage with you around pilot programs and more fully understand the parameters associated with your particular business case. So we'd be happy to engage in that conversation. And feel free to, you know, get in touch with your project team if you're an existing customer, or you know, engage with us if you're a prospect considering the solution or seeking to move forward on a pilot. And you can always connect with us via email at info@silverspringnet.com, and we can get started. So there's many paths to engage and move forward in the process. And then in terms of things that are coming up, as you know, this is a rhythmic process, and so next month in July, specifically July 16th, we'll have a session that focuses on customer engagement, some of the education programs and communication techniques that have proven you know, very helpful, you know, for smart grid overall, but particularly in terms of driving customer satisfaction in areas like demand response and you know, really managing the customer engagement process and driving customer satisfaction. And the perspective that we bring to that is again a systematic approach and grounded with our deployment experience. So that's it. We really appreciate the time that you spent with us, and thank you very much for joining. As I mentioned, there will be a recording that's available to you, as well as the slides for you to access on Springboard. So thank you very much.